welcome to True Projects. In this video, we are going to explain about the project that is identification of spam bots and fake followers on social network via interpretable AI-based machine learning. So before getting into the execution, first let us understand what is this project about. Social media platforms like X, which used to be called as Twitter, are major places where people connect, share information, and also have conversations with millions of others all over the world. They let us communicate quickly and also access news, updates, and ideas almost instantly. But these platforms aren't always just human talking to each other, they are also automated accounts like bots. So, some bots are harmless and even helpful, like those that share news or educational content. However, there are malicious bots like spam bots or fake followers which spread false information, fake news, or try to influence people's opinions. So these bots can create confusion, amplify harmful content, and also make it harder to, that is, for genuine conversations to happen. And right now, detecting bots on social media isn't easy. Most of the methods we have used are complex machine learning models, often called as black box models, which basically means we don't really know how they make their decisions. On top of that, figuring out what features or patterns to look at, like posting behavior or follow activity, usually needs a lot of manual work and it doesn't always keep up when both change their tactics. Here, another major challenge, that is another big problem, is that many models work well on the specific types of bots or data sets they were trained on. When you try to use them in a different situation, their accuracy drops. Because of all this, we really need a new approach that is easier to understand, more reliable, and also can adapt to different kinds of bots. So that social network stays trustworthy and also safe for everyone. So to overcome with all such issues, the system we are proposing is basically a smart AI tool that can detect spam bots and fake followers on social media platforms like X, which was Twitter. The key thing is that it is not a black box. It is designed to be understandable. So you can actually see why it makes decisions that it does. So the system works with few important ways. It works in few important ways. First, it analyzes a wide range of features from user profiles, tweet content, engagement patterns, and even language and sentiment. By looking at these details, the model can spot patterns that are commonly in bots but unusual for real users. Next, it ensures that data used for training is balanced. Often, there are many more real human accounts than bots. So, if we don't balance the data, the system might just learn to always predict human. Techniques like SMORT and undersampling are used to make sure that model treat both the classes fairly. And another key aspect of this project is using explainable AI models. So the system, it uses interpretability models that are SHAP and LIME, which helps to explain how each feature like number of followers, frequency of posts, or sentiment in tweets affects the model decision. This is really valuable because it builds trust so people can see exactly why an account is flagged as bot. And here, the system is also robust and adaptable. It uses multiple machine learning models and cross validation techniques to make sure it works well on different types of bots and datasets. So, even as bots evolve and change their behavior, the system can continue detecting them accurately. Finally, the model ranks features based on their influence. This helps stakeholders understand which characteristics are most important in detecting bots and providing insights into bot behavior. So, in short, the system is not just about detecting bots accurately, it is about making the process transparent, trustworthy, and reliable. And as an extension to this project, we have added several improvements to make the system even more effective and also user friendly. So, first, we have applied feature reduction along with the sampling technique. So, first, we have applied feature reduction along with the technique called smoothing sampling. This helps the model deal with imbalanced data, basically when there are many more human accounts than bots. And it improves the model's ability to correctly identify spam bots, especially using stacking classifier model. So as an extension, we are incorporating stacking model, which is an ensemble technique that combines multiple models. Then coming to live data integration. So we have integrated live data from X, that is formerly we known as Twitter, using a library called Wicket. This means the system isn't just trained on the old data, it can now fetch real-time tweets. Users can enter a tweet username and specify how many tweets they want to check, and the system will predict whether each tweet is spam or not. Then coming to the front end of this project, so we have developed a front end interface using Flask framework. This provides a simple interface that is simple and interactive way for users to input data and see predictions. And the interface also includes user authentication to ensure that only authorized users can access the system. So this is what we have done as extension. Now moving on to the implementation of the project. So these are the steps followed to implement it. Let us understand how we have implemented this project. First, we have imported all the necessary Python libraries like pandas, numpy, scikit-learn, and others. So these libraries help us to process the data, train models, and create the web application. Then comes data ingestion. So here we take the Cresci dataset as input and load it into pandas data frame. This makes it easy to process and manipulate the data for next steps. Then comes pre-processing. So here, once data is loaded, we clean it for the feature-based data. We handle missing values by either dropping them or filling them in. We also encode categorical labels so that the machine learning models can understand them and standardize numeric features to keep everything on a similar scale. Then comes feature selection part. So to make our models more efficient and accurate, we reduce the number of features using a method called recursive feature elimination, or we call it as RFE, which helps to pick up the most important features for our extension model. Then comes data resampling. So here in the step, the data sets often have more human accounts than the bots. So we balance the data. For baseline models, we have used the techniques that is mode and random oversampling. For the extension model, we have used smoothing technique, which is more advanced and helps the model to handle imbalanced data sets better. After data balancing, we extract relevant features and split the data set into training and validation and also test sets. This allows us to train the model, tune it, and finally test it on unseen data to see how well it performs. Then comes model building and training. At this stage, we train various machine learning models on the prepared dataset to learn patterns that distinguish bots from human accounts. After that, we will be evaluating all the trained models on the test set using metrics like accuracy, precision, recall, and FN score. So we will be using confusion matrix to see where the model make mistakes, like false positives or false negatives. To make the system transparent, we have applied explainable AI techniques such as SHAP and LIME, which helps us to understand why the model makes a particular prediction. And we will be saving best performing model for the future use. And in the front end users, they will be able to provide input that will be pre-processed the backend. It will be pre-processed, it will be fed to the train model, and then train model will be displaying the outcome. And here, these are the models used to predict the Spambots. And to implement this project, basically we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. And software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So let's open the code folder. These are the source code files of the code folder of the project. Let's understand each of them. How will they be used in this project? In this folder, we have the dataset that is used. So here we have used two different datasets, that is Cresci 15 and Cresci 17. Let's open it. And here we have files in this folder and also files in this. So we will be taking dataset from this. And coming to the model folder, in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder. So inside this, we will be having CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. It contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have test cases that we will be using in the front end. And here we have app.py file. So this .py file, it contains information related to front end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have two Jupyter Notebook files. And this is also a Jupyter Notebook file. So these files, I mean these Jupyter Notebook files contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have pre-processed dataset files. And here we have feature extraction app.py files, and this is database file, which I mean in this file, user information will be stored. So this is all about the code folder. Now let's execute it. To execute, we need to copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open Anaconda prompt. So it is open. Give the command cd, give the space, paste the copied path, and click on enter. So here you can observe current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command, it will execute Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. So copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to log in first. Click on login. Before logging in, ensure that you are registered. So click on register and enter all those details and create an account. I have already registered, so I'll directly log in. Give your username and the password. Now click on login. We have logged in successfully and redirected to prediction page of this project. So here we will be doing two kinds of prediction. One is with the live data and the other one is with the static data. With live data, by giving usernames, you will be directly extracting information from the Twitter and then you will be writing the information. So first let's do prediction with the static data. Click on that. So here we need to fill in all these details. That is followers count, friends count of that user, status count, favorite count, listed count, verified whether that account is verified or not, date when that profile was created, default profile, whether it is default profile or not, profile description, and tweet text, that is one or more new line separated. So let's start entering them. So let's open sample file. So for that, open test cases, open static samples. So let's check with the first case. Where follower count is 17, friends count is 263, status count is 205, favorite count is 1, listed count is 1, verified is false, that means it is not verified. Created date is June 2025, that too 20th June of 2025. So let's select the month, select the year, June 20. Where is it 20? So here is 20. And default profile. So here we have default profile as true, that is yes. And copy the profile description, copy it and paste it. And here tweet text. So paste it. Now click on predict. So this given information, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us the prediction. So here you can observe we got prediction as bot, that it is the bot created account. It is not the human account. And these are the feature values where this is the follower count, actual follower count, friends count, status count, favorite count. So in this way, we have all the features extracted. Now let's try with the other case. So let's check with this case where follower count is 89, friends count is 12,345, status is 5, favorite count is 9, listed count is 3, verified is no, it is not verified account, false means no, and created is 2020 July it is. So year is 2020 selected. Year is July 2nd it is. And give the default profile as no. Description is hello everyone. So paste it here. And here we have default. So default profile is false. And here tweet text is this, copy it and paste it. Now click on predict. So here you can observe prediction result is boat and these are the feature values. Now let's check with this case. Click on predict, click on static data and give the follower count, that is 7. Friends count is 324. Status count is 3666 and favorites are 6. Listed is 1. Verified is 1. That means it is yes. Sorry, we have entered it wrongly. So here follower count is 7, 324, 3666, 6. 1 is listed count and then verified it is false. That means no. And created on September 2020. So select the year, September 25. And profile is false, that is no. And here we have description, copy it and paste the text. Paste it. Now click on predict. So here we got the prediction as it is human. So this tweet account is of human and these are the feature values of that account. Now let's check with the live data. So click on live data and let's open these cases. So open real time. Here in this, we have some bot accounts and here we have some human accounts. Let's check whether the application will predict it correctly or not. So let's open this account. I mean this, copy it, get back, paste it. And you can select tweet count, which is 24. Let's give it as 24. Click on check bot or human. And here we got the prediction that it is bot. You can observe application is correctly classifying it as bot Twitter account. And here we have related extracted features, which is live. So these are the live extracted features. So here we have tweet ID for the given username. And this is the tweet text. So here we have total 24 tweets and the related information for the 24 tweets. Here we have follower count, friends count, status count, favorites count, list count, verified it is verified or not. Then we have accounted age days. In this way, we have all the different features of that particular account. Now let's try with other. Click on try again. Let's try with this username. Get back. Paste it. Let's give tweets as 100. Now click on check bot. Here we got the information. Here we got the prediction that it is bot. And here are 100 tweets of that user. And here we have tweet ID, tweet text, follower count, friends count, status count, favorites count, listed count, verified. Now let's check with the other username. So click on try again, get back, open human notepad. So let's check with this account. Copy it and paste it. So let's give tweet count as 50. And here we got the prediction that it is human. And here are the extracted tweet features. So here you can observe live features have been extracted of the 50 tweets. Now let's check with the last tweet. Click on try again. Let's try with this user ID. Paste it here. Let's give us 5 tweets. Click on check bot or hue. Here you can observe this is the tweet we have given and here we have 3 extracted tweet features for the 5 features. That is, here we got the prediction as human, and here are the extracted 5 tweets for that human tweet account. And here are the followed tweet features. Now let's check with the graphs. So let's click on Cresse 15. So here we have class distribution of Cresse 15 dataset, where on x-axis we have human and bot, and on y-axis we have count. You can even download the image. So let's close it. And here we have ROC, AUC, confusion matrix, and ROC, AUC curve graph. Let's close this. And here we have accuracy comparison score. Accuracy comparison graph. Here on x-axis we have all the models that we have trained, and on y-axis we have accuracy score. Close it. Similarly, we have precision score, recall score, and FN score. Now let's check with graphs of Cresse 17. And here we have class distribution. Close it. And here we have confusion matrix. Close it. Here we have accuracy of all the models, precision, recall, and FN scores. Now click on logout. So this project, it helps us to keep social media safer by spotting the bot accounts and the human activities. It is like having a smart assistant it can tell real users from the bots, making online interactions more genuine and trustworthy. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.